So we continue with the Avogadro's law and the applications of Avogadro's law. So first of all is the determination of atomicity of the gas. So atomicity of a gas, the number of atoms present in one molecule of that element is the atomicity. So if it is monoatomic, that means the molecule is made up of only one atom. If it is diatomic, the molecule is made up of two atoms. So the number of atoms present in one molecule of that element is monoatomic elements having which has one atom in their molecule like helium and neon, and diatomic elements which has two atoms in their molecule, that is hydrogen, oxygen, chlorine. So the application of Avogadro's law for determining the atomicity of nitrogen. So we know it is observed that one volume of nitrogen reacts with one volume of oxygen to produce two volumes of nitric oxide. So one volume is of nitrogen plus one volume of oxygen gives you two volumes of nitric oxide. So automatically one molecule of nitrogen with one molecule of oxygen will give you one nitric oxide, two nitric oxide, and half molecule of nitrogen with half molecule of oxygen will give you one molecule. So half cannot be, atoms cannot be divisible, that's why we take it as one. So atoms, one atom of the oxygen, one atom of nitrogen, oxygen and one atom, nitrogen will give you two atoms of nitric acid. So an atom is individual, therefore half molecule contains one atom. So therefore one molecule of nitrogen contains two atoms. So if half atom contains, you are given over here that half molecules contain one atom, because half plus are giving you one, so half तो possible होता नहीं है, तो automatically if what is required, that half is equal to one, so automatically 2 is equals to 2 atoms is equal to one molecule. Half molecule is equals to one atom, so one molecule is equals to two atoms. This is how you are finding out the atomicity of the number. So atomicity of nitrogen. Similarly, we can also compute with nitrogen and hydrogen giving you ammonia. So we know that one volume of nitrogen with three volumes of hydrogen gives you two volumes of ammonia. So one molecule plus three molecules give you two molecules. So accordingly, you will find that half molecules give you one molecule. So and one and a half molecule gives you of hydrogen will give that. So accordingly, you will get nitrogen half molecule is equals to one atom. Therefore, one molecule is equals to two atoms. This is how we are determining the atomicity of this thing. But anyway, not important because they have not been asked any time, but just for your understanding. Secondly, determine the molecular formula of a gas. A molecular formula, a chemical formula which gives the actual or exact number of atoms of an element present in one molecule of a compound. So it has been determined that is the same example. We are taking another example. Hydrogen plus chlorine give you hydrogen chloride. So H2 plus Cl2 is going to give me 2HCl. So one volume plus one volume, two volumes. One volume plus one molecule for one molecule is two molecules. So 2 into 1 atom and 2 into 1 atom is equals to 2 molecules. So that's why hydrogen and chlorine both are diatomic. A molecule of hydrogen and chlorine contains two atoms and therefore diatomic. Therefore, one atom of hydrogen combines with one atom of chlorine to give you one molecule of hydrogen chloride. So, molecular formula of hydrogen chloride is HCl. So, because both दोनों का एक एक is giving you HCl over here. Again, not so important. Next is determine relation between molecular weight and vapor density. Now, this formula is important, and you need to remember this thing. Molecular weight is the ratio of the weight of one molecule of substance to the weight of one atom of hydrogen. So that's why molecular weight is one mass of one molecule of substance upon mass of one atom of hydrogen. It's something similar to the relative atomic mass, but molecular mass. But only thing is that यहाँ पे हम लोग फिर भी hydrogen ले रहे हैं. We are not taking 1/10 of the carbon. So we are saying one mass of one molecule of substance upon mass of one atom of hydrogen. And the vapor density is the mass of certain volume of gas or vapors of the mass of the same volume of hydrogen. So volume measured under same temperature and pressure conditions. So if I am having a certain volume of or gas of or vapor of certain things, and upon the mass of the same volume of hydrogen, that will give you the vapor density. So this is important. vapor density is equals to mass of certain volume of gas or vapor upon mass of same volume of hydrogen gas. Okay, so mass of same volume of hydrogen gas, यानी अगर मैंने यहाँ पे 1 liter of gas लिया तो I'll have to take 1 liter of hydrogen gas. So that is the vapor density. The vapor density is mass of a certain volume of gas upon mass of same volume of hydrogen gas. So by Avogadro's law, we can see that Avogadro's law, volume at same temperature and pressure substituted by molecules. So we get vapor density is equal to mass of one molecule of gas upon mass of one molecule of hydrogen. Therefore, vapor density of mass of one molecule of gas upon 2 atoms of hydrogen. So that is why when we multiply this thing, we get that 2 into vapor density is equals to mass of one volume of gas upon mass of one volume of hydrogen, which is nothing but the molecular mass. So yeah, we forgot that thing. Molecular weight, molecular mass भी चलता है, weight भी चलता है. So it's the same thing. We are not in physics where mass and weight are different. So molecular weight is equals to mass of one molecule of gas or vapor or substance, we can just say, of substance upon mass of one molecule of hydrogen. Okay, so sorry, one atom of hydrogen. So now you see that molecular weight is mass of one molecule of substance upon mass of one atom of hydrogen. Now here, if I take that mass of certain volume of gas जो दिया है उसके बदले if I take one volume, so it is, suppose I take vapor density is equals to mass of one molecule of gas upon mass of one molecule of hydrogen. Now you know the hydrogen is diatomic, so it is 2 atoms of hydrogen. So it is mass of one molecule of gas upon mass of 2 atoms of H2 hydrogen. Now 2 atoms of hydrogen means ये अगर if I see this one, it is mass of one atom of hydrogen. So I need to see over here 2 is equals to mass of one molecule of gas upon 2 into mass of one atom of H2. This 2 goes over here, so this is Vd. So we get over here 2 into Vd is equals to, now this part, mass of one molecule of gas upon mass of one atom. So this is nothing but one molecule substance of this is the same thing. So there is a molecular mass, so that is molecular weight. So we have over here that molecular weight is equals to 2 into vapor density. This is a derivation but not required to learn. But yes, you should remember the formula that molecular weight or relative molecular mass, we can also see as that relative molecular mass is equals to 2 into Vd. Okay, relative molecular mass of a gas or a vapor is twice its vapor density. So this is the very important part. You need to learn this part because it will be required for you to use this when you are using the next part of the chapter, that is empirical formula. That explains that Gay-Lussac also explains the Avogadro's law explains the Gay-Lussac's law of combining volumes. So 2 volumes of hydrogen chloride for one volume of hydrogen and 1 volume of chlorine. So 1 volume of hydrogen, 1 volume of chlorine gives me 2 volumes. So it is in the ratio 1:1:2. So 2 atoms of hydrogen with 2 atoms of chlorine will give you 2 molecules of HCl. So 1 molecule of HCl is formed by 1 atom of hydrogen and 1 atom of chlorine. Again, not so important. Conclusion: Thus Avogadro's law that equal volumes of gases under the same condition of temperature and pressure contains the same number of molecules explains Gay-Lussac's law of combining volumes. The next is relationship between gram molecular mass and gram molecular volume. So we are given that gram molecular mass is the relative molecular mass of substance expressed in grams, also called as gram molecule of the substance, and gram molecular volume is the volume occupied by 1 gram molecular weight of gas at STP. So that is 22.4 liters, what we talked about last time. Well, now about a few minutes back. So according to Avogadro's law, equal volumes of all gases under the same condition of temperature and pressure contains the same number of molecules. Therefore, equal number of molecules of different gases under the same condition of temperature and pressure will occupy same volumes. Right? Obviously, because again equal volume of gases have got equal number of particles, then automatically equal number of particles will have the same number of volume. But 1 mole of a gas contains 6.023 into 10 to 23 molecules occupying the same volume at STP as 1 mole of any other gas. So the same volume is the molar volume of the gas, that is gram molecular volume is a gram molecular weight upon weight per liter, or we can say it as, that's why it is 32 grams of weight, that is the molecular weight of oxygen, and the gram per liter is 1.429, therefore the molecular that will be 22.4 liters. Similarly, for hydrogen also is the same thing, 2.106 is the molecular weight and gram per liter is 0.09, therefore the total in 1 GMM is 22.4 liters. So the conclusion is that the gram molecular weight of any gas occupies 1 gram molecular mass volume or molar volume, which is equal to 22.4 liters at STP. So this is what is the derivation for 22.4 liters, which as such not required to by heart or learn. It is just for your understanding this particular thing more better. So always the main thing what you need to remember in case of stoichiometry is that 1 mole is equals to GMM of the substance is equals to 6.023 into 10 to 23 particles, and which is equals to 22.4 liters in case it is a gas. So we summarize this way, that a mole is an amount of substance which contains the same number of units of the number of atoms in 12 grams of carbon, particles, atoms, molecules of ions equal to 6.023 into 10 to 23, that is Avogadro's number. Relating mole and atomic mass, 1 mole of an atom weighs 1 gram atomic mass of an atom, that is, for example, 1 mole of oxygen atom weighs gram atomic mass of oxygen 16 grams. Gram atom is mass of the atom upon relative atomic mass, and relative atomic mass of an element is the number of times the weight of the number of times an atom of an element is heavier than 1/12 the mass of 1 carbon atom. Relating mole and molecular mass, 1 mole of an element of any substance weighs 1 gram molecular mass of a substance. For example, 1 mole of oxygen molecule weighs, molecular mass of oxygen is 32 grams, and gram molecule, that is mass in grams of substance upon relative molecular mass. Relative molecular mass is molecular weight. It is the number of times 1 molecule of a substance is heavier than 1/12 the mass of a carbon atom. That's why I have 1 mole of a gas weighs 1 gram molecular mass, occupies 22.4 liters, that is the molar volume, and molar volume occupied by 1 gram, that is 1 gram molecular mass of the gas. So that's why we have the final thing as 1 mole. I write it down. So that's the main thing. 1 mole weighs 1 GMM. Okay, weighs gram molecular mass, not 1, will be GMM, weighs GMM of substance. and it has occupies 22.4 liters or 22400 ml, okay, or cc, that will be ml, or you can say cc, and it will contains 6.023 into 10 raised to 23 particles. This is the basic mole concept. This thing is the mole concept. Okay, 1 mole, what is it? 1 mole weighs gmm of the substance. 1 mole of oxygen, gm of oxygen 32. So 1 mole of oxygen weighs 32 grams. 1 mole of NaCl. So NaCl का क्या है? Na is 11. Sorry, not 11. I just 23. Yeah, Na is 23 and this 35.5. So it is 58.5. So 1 mole of NaCl weighs 58.5 grams. It is containing 6.023 into 10 raised to 23 particles. You cannot have the volume of that thing because NaCl is not a gas but a solid. Okay, so this is about the mole concept and the mole part. And now we have got the numericals based on these ones. So we have got the numericals based on the mole concept, the Avogadro's number, right? So that is the thing given to you, and then there are some sums. Yeah, so we have got around 25 sums over. We'll do the additional sums. Now before that we can just go through 1 or 2 examples. Now if you see the main the sums of these particular kinds, or in case of mole concept, they are much more like you are doing unitary method. Okay, मैथ्स में जब यूनिटरी मेथड करते हैं ना, वैसा ही है ये कि 1 kg इतना तो 10 kg का कितना, ऐसा ही है. It's something like this because you know that 1 gmm is equal to be 1 mole is equals to 1 gmm. So 0.1 mole will be how much, or 1 gram is this much, so this many liters, so ये कितना, you know, it is just like unitary method. So you will be having very much similar to those things. Let's see one example over here. The first one will be the first example. First example is that calculate the number of moles in nitrogen of 7 grams of nitrogen. So we got 7 grams of nitrogen, and you need to know that what is the number of moles present in it. Now you know that N is equals to 14, so N2 is equals to 28 grams. So we know that GMM is 28 grams. So we know that 28 grams of N2 is equals to 1 mole. Therefore 7 grams of N2 is equals to X mole. So X into 28 is equals to 7 into 1. X is equals to 7 upon 28. That's 1 upon 4. So it is X is equals to 1 upon 4 moles. So it's 1 upon 4 moles of nitrogen. You can see it's very simple. That's or you can write it as 0.25 also, not a problem. 0.25 moles of nitrogen will be the answer. We'll now see the sum number. Let's take 5. Okay. Calculate the atomicity of a gas X if 1 gram of X occupies 11,200 cc of at STP. So you are given that atomicity, you need to find out that X 1 gram of X occupies. So 1 mole, so which is form number 5, we have got 1 mole weighs the GM. You don't know the GMM, you need to find out the GMM first. So you need to find out the GMM and then you can use that thing. So we have over here 1 mole weighs GMM is equal to 22400 cc, right? Therefore you know over here 1 gram, so therefore X grams is equals to 22400 cc, where 1 gram is equals to 11200 cc. Therefore, x into 11200 is equals to 22400. So x is equals to 2. So therefore 2 grams. Okay. So we know over here that it is 2 grams. So atomicity, the formula is gmm upon atomic weight. Okay, gmm upon atomic weight. So over here it is 2 upon 1. Why? Because atomic weight was 1. Because atomic weight is given to you, atomic weight of x is 1. It is already given that atomic RAM is equals to 1 gram. Diya hua hai. Okay, so that is why it is 2. Atomicity is 2. Okay, that was sum number 5. Now we move on to sum number 10. Let's see sum number 10 now. One mole of SO2 occupies 24 dm cube at room temperature and pressure. Calculate the following at room temperature and pressure. The mass of 6 liters of SO2, the volume of 80 grams of SO2. Okay, there are many things, so let's go one by one. So we have got over here 1 mole of SO2 occupies 24 dm cube at room temperature, that is not STP. At STP it would be different. So first of all, you can see that 64. Now you know that SO2 is nothing but 32 plus 32 is equals to 64 grams. So it is given that at a particular room temperature 64 grams is occupying 24 liters. So at room temperature 64 grams occupies 24 liters, because dm cube and liter is one and same. Now first question they asked is the mass of 6 liters of SO2. So we have therefore x grams occupies 6 liters. So 64 into 6 is equals to x into 24. So x is equals to 64 into 6 upon 24. 6 4s and 16s, that will be 16 grams. So first thing is the mass of, first one, mass of 6 liters of SO2 is 16 grams is equals to 6 liters of SO2. You see the second thing now? Again, the volume occupied by 80 grams of SO2. So we know over here that 24 grams, what is that? 80 liters of SO2. Okay. So we know that 64 grams occupies 24 liters. Therefore, 80 grams occupies Y liters. Okay. So therefore, Y is equals to 24 into 80 upon 64. 8 8s, 8 10s, 8 3s is equals to 30 liters. So the answer is 30 dm cube or 30 liters. The third part, the number of molecules in 0.64 grams of SO2 if 1 mole of SO2 contains n molecules. So they are given that 1 mole of SO2 has n molecules. Therefore 64 grams of SO2 has n molecules. So 0.64 grams has Z molecules. Therefore Z is equals to 64, it is 0.64 into n upon 64. Okay, so that will be hundreds of, that is n upon 100 molecules. So the number of molecules in 0.64 grams of SO2 will be n upon 100 molecules. They are taken the capital N, so I'll take it as n only. Next is the weight of 0.5 gram molecules of SO2. 0.5 gram molecules. Now do not make a mistake. 0.5 gram molecules जब भी दिया है तो it is not going to be 0.5 grams. It is 0.5 gram molecules. So it is like 0.5 g gram molecules is equal to 0.5 into GMM. That is nothing but 0.5 into 64 is 32 grams. So weight of that much is 32 grams of SO2. Alright, this is the kind of questions you are going to have. Next we have is problem based on, I'll take one more, one from this two, that is mole concept में Avogadro's law के ऊपर से. If 100 cc of gas A contains Y molecules, how many molecules of B will be present in 50 cc of B and gas 25 cc of B? So it is this way. So what we have is the 14 sum is if 100 cc of gas A contains Y molecules. So 100 cc of A has Y molecules. So 50 cc of B will have let's take it as X. So X into 100 is equals to 50 into Y. Therefore X is equals to 50 into Y upon 100 is equals to Y upon 2 molecules. Similarly 25 cc of C will have Z. So Z into 100 is equals to Y into 25. So Z is equals to Y into 25 upon 100. So that is equals to Y upon 4 molecules. This is how you are going to calculate using the Avogadro's law at equal volumes and equal masses, equal number of molecules in them. So अगर ये 100 cc है तो Y है, तो 50 cc है तो half of that. 25 cc will be half of this 50 also. So it is 1 upon 4 or Y upon 4. We'll see now one related to vapor density. So let's see the sum number 19. That's the last sum of the solved examples. So that's sum number 19. KMnO4 decomposes on heating according to the equation KMnO4 gives you K2MnO4 plus MnO2 plus O2. K2MnO4 and MnO2 are the solid residues. On heating KMnO4, 1 liter of oxygen was collected at room temperature and was found that a test tube had undergone a loss of mass by 1.32 grams. If 1 liter of hydrogen under the same condition of temperature and pressure has the mass of 0.025 grams, calculate the relative molecular mass of oxygen. So first of all they have given us that 1 liter of oxygen. See, it's a complete story what they have built up. Actually कुछ उनपे important था नहीं. Important क्या था कि oxygen कितना मिला volume wise and what was the mass wise. So we know that over here they are given that 1 liter of oxygen was collected at room temperature and was found the test tube had undergone a loss of mass of 1.2 क्योंकि oxygen निकल जाएगा तो क्या बचेगा उसमें सिर्फ बचेगा K2MnO4 and MnO2. So whatever is lost is oxygen. So oxygen which is lost, which is 1 liter, is having the mass of equal to 1.32. So we see that weight of 1 liter of oxygen is equals to 1.32 grams. Okay, that is weight of 1 liter of oxygen is 1.32 grams. And accordingly, we also see that what will be the weight of 1 liter of hydrogen? They are given that 1 liter of hydrogen under the same temperature pressure conditions is going to be 0.05. So we know over here that vapor density is weight of 1 liter of O2 upon weight of 1 liter of H2, because that is basically the formula for vapor density, that mass of certain volume of a substance upon mass of same volume of hydrogen. So we are given over here that this is 1.32 and this is 0.085, 0825. Okay, so when you cancel this, you come to know that it is 16 times. So that's why it is 16. So vapor density of oxygen is 16. So vapor density of oxygen is 16. So now we know that molecular, what is the relative molecular mass? So relative molecular mass is equals to 2 into Vd is equals to 2 into 16 is equals to 32 grams. So the oxygen, the molecular mass of oxygen is 32 grams. So this was about the mole concept, Avogadro's law, and the vapor density types of questions, right? So we now go through the different questions which are given here. There are totally 31 of them, so maybe we're going to take some long time to complete this part. So let's start with them in the next video.